One of the enduring mysteries of medicine is what causes autoimmune diseases like lupus, multiple sclerosis and rheumatoid arthritis. They affect millions of Australians. The cause of this type of disease, where the immune system attacks a healthy part of the body, is unknown and there's no cure. But now a controversial theory advanced by a surfing scientist is exciting the world of medical research, as Lisa Whitehead reports.
Surfing is in Chris Goodnow's DNA. His pursuit of the perfect wave led to his first exciting discovery.
We came around one headland and there it was, sort of the holy grail.
In 1980, Chris Goodnow, his cousin and a fellow science student trekked to the Mentawai Islands off the coast of Sumatra. They discovered a place that's now considered to be one of the top 3 surfing destinations in the world.
It gave me the appetite for the idea that if you really plan an expedition and you do your homework, you can really set off into the unknown and have a great adventure and actually discover things that no one had seen before. Okay, well that's good. Okay, I'll go look at this place.
He's taken that quest for adventure into the laboratory. 30 years on, Chris Goodnow is Professor of Immunology at the Australian National University.
It was a bit the same mystery. Oh, I've got to understand this immune system. It's you know, like uncharted islands, clearly important for so many diseases, but no one's been there.
His pioneering research led to the first new treatment in 40 years for lupus, which is one of the 100 known autoimmune diseases. Now he could be on the brink of solving one of the great medical mysteries, finding out what causes the immune system to attack healthy parts of the body.
We are really on the threshold of getting to the root cause of the disease.
Professor Chris Goodnow has devoted his life to understanding autoimmune disease and lymphoma. Both diseases have affected his own family.
Hi, Mum.
Hi, Chris.
He lost his father to lymphoma, and his mother Jacqueline has suffered from lupus for 50 years.
While, you know, I may get very passionate about just the pure science, there's a real personal human dimension to it.
Tonight, Professor Goodnow's work is being recognised with the prestigious Award for Research Excellence. But his theory about what causes autoimmune disease is controversial.
Safe science doesn't go outside the box. And this is definitely going outside the box. Real thing, yes, absolutely.
Professor Ian Fraser, who developed the cervical cancer vaccine, nominated him for the award. He says the $80,000 prize money, donated by drug company GlaxoSmithKline, will allow Professor Goodnow to put his theory to the test.
Funding from somewhere where they're prepared to take a risk is actually very valuable in science because it allows people to challenge the dominant ideas and maybe change the way that we think about a whole field.
While it's accepted genetics plays a role, it's also been thought a range of factors, including the environment, viruses and diet, could be the trigger for the immune system to attack. Controversially, Professor Goodnow and his team believe autoimmune diseases like lupus, multiple sclerosis and rheumatoid arthritis that have very different symptoms have one root cause: rogue white blood cells, similar to those that cause the blood cancer lymphoma.
So the roots of those, the rapid growth of those lymphoma cells are particular sets of mutations. And what we hypothesise and are now in a place to test is that some of those mutations are also at the roots of the rogue cells that are driving autoimmune disease.
Canberra Hospital's Director of Immunology, Dr Matthew Cook, is collaborating with Professor Goodnow's team in the trials.
It's controversial until we can substantiate it with experimental evidence.
Blood and saliva samples will be taken from his patients, like Nicole McGee. She suffers from a chronic inflammatory autoimmune disease called Sjogren's syndrome, a disease that attacks moisture in her body.
What we'll do is sequence the DNA from those blood cells very deeply using a technology that really only has just become available in the last year or so. And that will allow us to detect that even if 1 cell in 10,000 or 1 cell in 100,000 has acquired one of these mutations that we believe could be at the root, we'll be able to detect it.
If Professor Goodnow is right, it has huge implications for the treatment of autoimmune disease.
That would give you a clear path for some of these new anti-cancer drugs to be applied to treat autoimmune disease.
The results should be known within 12 months and have the potential to transform the lives of people living with an autoimmune disease.
They may be able to give more targeted treatment with way less side effects, and especially it seems like they're quite close. It's not years and years away, so it's really exciting.